going on, guys? Welcome back to the channel. In case you're new here, my name is Tyson and I'm a PhD candidate in chemistry at Yale and Berkeley. And listen, I'm going to put myself out there. What I'm going to say is that this is probably one of the best places on the internet to get quality information. I mean, if I do say so myself, not only do we have some A1 science communication, great tips and tricks for your academic journey, and some great conversations between intellectuals. The thing that we take pride in is that we do this in a very laid back form, right? Like, so it's basically like being at the barbershop or chilling at the lunch table, something like that. And so if this sounds of interest to you, definitely make sure you hit that subscribe button so you can keep rocking with us. All right, great. Now today we have a very, very special guest in the building. One of my close friends, Dr. Charles Brown from the Ultra Cold Atomic Physics Group at UC Berkeley, is here to chat with us today. So what we want to do is talk a little bit about his academic journey, to let him tell us a little bit about quantum physics, as well as I'd like to chat a little bit about a great article that he recently had published in Physics Today. And so Dr. Charles, how you doing, my brother?
I'm doing good. Good to be here. Big fan of the channel.
Appreciate it.
So like you just said, I'm currently a postdoc at UC Berkeley in an ultra cold atomic physics group. And yeah, it's been a long time coming, but I finally got my PhD. Very, very excited about it.
Congrats.
Yeah, thank you. I appreciate it. Yeah, so I got my bachelor's in physics at the University of Minnesota.
Okay.
There, I did a lot of research on magnetic materials, and I thought I was going to go study materials physics in grad school and study magnetism, but actually caught wind of atomic physics, and it kind of changed my whole perspective on like what I thought was the most amazing, interesting things.
Sure.
So yeah, I came across Jack Harris. He's a Yale physics, awesome person, by the way.
Cool.
And I really liked the group, and I really loved what he was doing. And fortunately, I got a spot in his lab, and I got exposed to atomic physics through him, and that kind of opened my mind. I didn't always know I was going to do physics.
Sure.
I had always wanted to do science, though. My mom, although she's not a scientist, she loves science. Huge sci-fi person, always talking about science, got me super excited about it when I was a kid. So I kind of always had an interest in science. I used to think that I was going to do some kind of biological science, but I've also always built a lot of stuff with my hands. I love building stuff. I tried to convert my mom's garage into a makeshift lab. Destroyed a lot of stuff in the process, but it was great. I loved it.
That's cool.
And so eventually I found out that I wanted to do engineering.
Okay.
So I started college, and I was doing a nuclear engineering major. And, I had this sort of romantic idea of I was going to go to the Navy and be an engineer that works on the nuclear reactors, maybe be a captain one day, travel the world, which I think would be amazing. But I think, at some point in my engineering classes, I realized the stuff that really got me going was the physics. I think everything about why things are the way they are and just how that goes about in nature, I just think is incredibly fascinating.
Yeah, definitely.
So I was like, okay, I got to make the switch from engineering to physics. I realized that physics was a thing that I was really passionate about. But, I'll say that it was also really important to me to do something where I could make some money. It's nice in taking the engineering route. There's definitely lots of opportunity for money. I come from a humble background. And so, being able to be like financially stable and like support myself and be comfortable, be financially free, be free in every sense that I can be was super important to me. And I convinced myself, and I believe it's true, that I can do that in physics. So.
Absolutely. That's great, man. Sweet. And so one of the things that we like to do on this channel is showcase this combination that this channel is about, right? The fresh professor. And so, the fresh being those things about you that you enjoy, things that you feel really make you as an individual outside of the science, right? As well as the professor, the habits of scholarship that you've adopted that made you so successful as an academic. And so would you mind sharing with us a little bit about what you would consider to be your fresh and your professor?
Yeah, absolutely. I really like weightlifting. I've been into weightlifting for a long time.
Okay.
Powerlifting, Olympic lifting. I was doing CrossFit regularly for quite a long time, and I'd like to get back to that whenever that makes sense again.
Actually, very quickly, fun fact, Charles actually used to do CrossFit with my my PhD advisor, which was a very interesting thing to find out. And so she loves Charles probably more so than she even loves me. And so,
that's true. And she is awesome. She is awesome. So I would say, definitely that. Also, I love being out in the wilderness. I love the woods, and I love being near water. It's kind of funny. I am from Las Vegas. I grew up in one of the hottest places on the planet.
Sure.
And I was not built for that. I'm a cold weather person, and I love lakes and just like forest areas. So I love being out there camping, start a fire, cook some food out in the open. That's perfect. I love that. So I'm looking forward to getting back to that when whenever that makes sense.
Sure. Actually, so a quick question on that. And so I think that one of a very common stereotype is that Black people don't like to go outside that much, right? And so I'm curious where you adopted the habit of going outside, cooking things over a fire, kind of the camping lifestyle.
Yeah, that's an interesting and important question. I do think a lot of people say that. I didn't grow up doing stuff in the wilderness.
Right.
I fished one time in my life. I don't know how to fish. I want to learn how to do that.
Uh-huh.
I don't know. There's something about just being human. I just feel called to be out, experiencing nature, experiencing the woods, being in touch with what it is that makes me human. I don't know.
Yeah. Have you hiked a lot around Berkeley?
It's that's also a good question.
Okay.
And let me make myself look like a hypocrite a little bit. Despite the fact that I really like this kind of thing, I have not done a good job of prioritizing doing that.
Sure. Yeah,
and
we
it's
do
too bad because there's amazing land around here. There's a ton of trails, all the hills, the mountains, the redwoods,
absolutely.
All this stuff. Absolutely. I need to experience it. I need to stop being so bogged down with the science, maybe.
Lab, yeah.
But
dude, I mean, something I definitely want to do more. So we should definitely check out one of these mountains or something in the near future. Yeah.
Oh, I'm down for sure.
Sweet.
Especially the redwoods. Got to go to the redwoods.
Yeah, for sure. All right, so yeah, tell us a little bit about your professor side, man.
Yeah, so let's see. Things that have made me successful. I would say hard work. I'm a very hard worker, and I think that working hard is important.
Mm-hmm.
Yeah, sure, talent is important. I guess it is important.
Sure.
But I think that working hard at something and identifying issues that you struggle with to address the things that are difficult for you, make forward progress, that goes an incredibly long way in life and especially science.
Right.
And so that's really important to me. Working hard, making goals, identifying, issues and addressing them.
Absolutely.
I would also say passion, I guess, and that's a bit of a tough one. But I'm fortunate that the thing that I'm very passionate about is physics. Right? I love the fact that we get paid to uncover the mysteries of the universe. It's the most amazing thing.
Yeah, absolutely.
And I think that if you can really embody passion for the work that you do, and you can combine that with something like hard work, it really provides a nice avenue for you to be a really great explorer, which is what scientists are. We are explorers, exploring nature at the end of the day. And so,
right.
I think those things.
No, definitely. I mean, that sounds great, man. Those are definitely some great tips for anyone looking to be the next Dr. Charles Brown out there. And so very quickly, the first thing I kind of want to get into is that what in the world is ultra cold atomic physics?
Good question. Okay.
Yeah.
So ultra cold atomic physics. It's atomic physics, which I'll say what it is.
Okay.
But it's atomic physics where the atoms are incredibly cold. How cold? We're talking like a billionth of a degree above absolute zero, the absolute coldest temperature allowed by quantum mechanics.
Right.
And it turns out that when you study systems of atoms that are incredibly cold, almost as cold as possible, a lot of really new, interesting quantum physics phenomena emerge. And so in our ultra cold atomic physics group, we use these systems of incredibly cold atoms to study all the interesting new states of matter that emerge when you throw a bunch of atoms together that interact with each other. You make them super cold.
Right. Okay, cool. So I'm a chemist, right? So system of atoms. What are you referring to there?
Yeah, so that's kind of like really central to the whole of what we do. So there are lots of ways to study, ultra cold atomic physics. One way that we do it is by making a lattice. And we make that lattice out of light. So imagine an egg carton. Egg carton is a series of little bowls right next to each other where the eggs sit. Okay, so instead of those little cartons, or instead of having eggs in the little bowls in the carton, imagine I throw marbles in there.
Okay.
Right. So I have a bunch of marbles in each one of the little bowls in the egg carton, and imagine that those marbles can hop from side to side. And imagine that when two marbles are in the same bowl in the same site, they have some kind of interaction.
Right.
So it turns out that if you can build that same kind of system in a really controllable way, you can learn an incredibly large amount about how materials work. Because in a material like a crystal, for example, that has a structure sort of similar to the marble in the egg carton, except for it's a series of atoms in some particular arrangement, and electrons can hop from site to site. electrons interact with each other. This is just all a way to simulate those kinds of systems. And so what we do is we make our egg carton out of light. Right? We can make this structure where if we throw atoms in it, the atoms tend to want to go to particular spots, and the atoms can hop from spot to spot, and they will interact with each other.
Right. That's interesting. And so these are some potential energy minimums or something.
These are potential energy minimums where the atoms like to hang out. That's right.
I see. Very cool. And so what kind of atoms, again, so this is where the chemistry is really kind of motivating the conversation here. And so presumably it matters what the atom is. And so do you guys do these experiments on particular types of atoms? Or
we do, yeah. So we use alkali metals typically.
Okay.
And that's because they are particularly easy to control because they're hydrogen-like. The outermost shell has a single electron. And so the energy level spectrum or structure is not horribly complicated. So what does that mean? That means that there are a series of well-defined gaps between energy levels that the electrons experience in the atom. And they happen to fall into very convenient wavelengths, like visible wavelengths, like, some red color or something like that, or some infrared color, something like this. And that's really great because we have really great lasers that have really great properties and a lot of great equipment to use. And we can use that light to apply forces to the atoms. So that means we can manipulate them. And that's actually how we cool them. It's sort of funny. People are really surprised to hear that I get atoms incredibly cold by shining light on them.
Right.
But if you do that in the right way, if you can shine light on them in the way that tends to make them slow down, which removes their kinetic energy, then you can make them very, very cold.
Interesting.
Yeah. And so let me finish answering that question. You asked me which metals or which atoms. So the alkali. So, rubidium, cesium, potassium, that whole, what's it called? A family, the column on the periodic table.
Sure. Yeah, the group. Yeah,
the group. Yeah. Okay. So a lot of the work is done there, but there's actually a bunch of really incredible work being done with other atoms. Say the next column over, I know people are doing really interesting cold atomic physics with strontium. People are starting to do ytterbium. My PhD advisor has this super cool new experiment where he's trying to make ultra cold titanium atoms. Fractions, tiny fractions of a degree above absolute zero, but titanium. This is very unique.
Wow. And then, so the last question I'll kind of ask there from the chemistry perspective is ionization less of an issue? So you talk about cesium and these kind of larger alkali metals, which have very low ionization potentials. But you said you're doing this at a billionth of a degree over absolute zero?
Yeah, so these things are incredibly cold. They are hardly moving, and we understand the energy level structure of these atoms very, very well. So we tend to send just the right light to be able to apply forces to them without heating them uncontrollably. Yeah. So we know how to do that very, very well.
That's pretty cool, man. And so what you're seeing here a little bit is I may be showing a little bit of my ignorance in the physics.
No.
It always fascinates me whenever Charles and I have these discussions because presumably atomic physics, he's working on things that one might think to be similar to chemistry, but then it's in a completely different world, which I always find fascinating. And so that's pretty cool. And so what are the next steps for you, man, in physics? So you're studying this atomic physics now. In your postdoc, what do you think you're going to do following this?
I want to keep doing it, but I want to do it as a professor.
Absolutely. Okay.
So yeah, I'm very, very much looking forward to being a professor. Some might think this is kind of silly. I don't. I think this is real and important. I think that universities, like the university system is, one of the most important things we've done as a species.
Right.
And I really want to take part in leading it into the future. So, I anticipate doing that in part by finding an academic post in physics and doing my part to do awesome physics, but also sort of shepherd academia into the future.
Right. And so you're thinking more R1 versus
Yeah, I'm thinking the big research university
kind
of thing. So, interesting thing about the science that I do, it's very expensive. And while there are a ton of really awesome universities out there that I would love to be at, I think that there's a certain kind of university that has the infrastructure to do certain kinds of physics work.
Sure.
And so that sort of requires me to aim for, large research university. But all options are open.
Cool. Great. And so actually let's at this point switch gears quite a bit.
Yeah, okay.
So as you guys have probably noticed, both Charles and I are Black. and we study physics. I think that's pretty apparent about us. And Charles very recently wrote an excellent article that was published in Physics Today concerning his experience as a Black male in physics. I'll definitely drop that in the description below for any of you who are interested in checking it out. I would highly recommend that you do so. But Charles, do you mind kind of chatting a little bit about this article with us? It's such a big topic. Yeah. So do you want to start by giving us a little bit of a synopsis of the article that you wrote for those who haven't been able to check it out yet?
Sure. Yeah. So, I wrote an article that appeared in Physics Today about the Black experience in physics. And I really tried to nail the Black experience in a way that sort of speaks to all Black people. Of course, I'm a Black man, but I'm not the only Black person in physics. And so I tried to touch on all of this as much as I could. But in this piece, I talk about my trajectory, my backstory, and difficult experiences that I've had in physics. These experiences being, very powerful barriers to making it to the next step, or really just persisting in the discipline. In this piece, I also talk about common problems that, Black students face in physics, what people call microaggressions or overt racism, be it interpersonal or systemic, and how, sort of at each step of the way, undergraduate to graduate to postdoc to junior faculty up to tenured faculty, there are very interesting examples, definitely in other disciplines, of powerful systemic bias that can make it very difficult for us to make a jump from one step to the next.
Right.
So I try to talk about all of that and how, these things also look a little bit different. Say if you're a Black woman as opposed to a Black man, because being a Black woman, you're both Black and you're a woman, which means that you have to deal with this compounded bias. And it's actually, really wild fact that only about 100 Black American women have their PhD in physics.
Wow.
There's a really great website that lists these women and women who are soon going to have their PhDs in physics and astronomy. It's aawip.com, African American Women in Physics. Definitely check that out. And so, in this article, I talk about, the evidence in a very high profile scientific paper, mind you, of anti-Black bias against postdocs and postdoc hiring. I also talk about anti-Black bias in awarding grant funding to Black scientists from a national, science funding organization. I also talk about, anti-Black bias in citation of Black scientists' research, right? So all these things are very important for being successful, making it to the next step. As a professional scientist, you need to be able to win money for your work, and you need to be able to disseminate your work, and people need to cite your work, right? Your work needs to be part of the mix. And so I talk about that. And I finish with a call to action where I describe hey, you need to include us. What does that mean? Well, you definitely need to start with admitting us and hiring us, but that has to come with the creation of an inclusive environment where you don't have to deal with all these extra barriers that other people don't have to deal with, only to have people say, oh, look, he didn't succeed. He did exactly what I thought he would do.
Right.
So yeah, that's what that was about.
Definitely. So, because from an outside perspective, I think that all of STEM is pretty non-diverse, but it always seems from the outside looking in that physics is kind of like one of the least diverse parts of STEM. Do you have any thoughts on that? Like why it may be that physics is particularly exclusionary?
I find that to be a very complicated question. And actually I've thought about that quite a bit, and I don't know. Yeah. I mean, physics is a very old discipline, right? A long time ago, physics and philosophy were sort of intertwined, right? Physics has existed for, as a thing people study, physics has existed for a long time. And I think because it has existed for such a long time, old ways, old thinking are very much cemented into how we have built the academic system that is physics. Right. And for that reason, it's controlled people's perspective or opinions of who can do physics, who is good enough, who is smart enough. And, when you think about, people often associate doing physics with having intelligence. Well, there are also lots of racist tropes about how Black people are less intelligent. It's completely nonsense, but it exists. And so, then it's that all plays into, I think that all plays into, why physics, the demographics look the way they look.
Yeah. And so this is interesting. And so would you say that a lot of the discouragement, or would you think rather that a lot of the discouragement is happening early on, even before they get to undergrad and graduate, et cetera, et cetera? Because I don't have the numbers in front of me, and it would be interesting to see, but most of the Black people in STEM that I interact with normally are in the biological sciences. And so based on what you're saying, basically my question is, do you think that there are fewer Black students who are applying to physics relative to the biological sciences, and that on top of the fact that the experience of being a Black physicist is difficult, that students are also being discouraged from applying based on the stereotypes that you just mentioned?
Yeah. Those are such important things to talk about. One of the last things you said, I think it is known, people please check this, that there are less people trying to do physics, or at least there are definitely less people completing physics degrees than biological degrees. And so there's a lot of data on this. You can find it on the American Institute of Physics website. They definitely have demographic information on like who is doing physics. You can also find this on the American Physical Society website. That's a thing. I think part of it does come from how we are socialized.
Right.
I think in a similar way to how, unfortunately, young women or young girls have thrust upon them this perception of their role in society. And sometimes people are doing a lot to teach them that, like, this is what you're supposed to be doing, not physics and math and engineering.
Sure.
I think a lot of that also exists for Black people.
Right.
I mean, I know certainly for me, people love to assume that I'm a, NFL player. And that's because I think society in many ways casts us into these boxes of what Black people do. And many people don't think about the fact that Black scientists exist. We are incredible scientific thinkers, and we have been for a long time.
Right.
Yet most of what they see is, maybe a certain segment of famous Black people who happen to be athletes or something like this.
Right.
And so, I do think that before you even get to an undergrad, physics major, there's a lot of societal stuff that has told you, and, in some unfortunate cases, convinced you that physics, STEM, all this stuff is not for you. So, yeah.
No, that's a really good point. And so what do we think, man? I want to chat about this a little bit. How do we combat that? And so how do we actually, so there's a tremendous amount that has to be done at the universities, and I don't want to take away from that, and we can come back to that in a second. But since we're on the topic, I'm curious of, I like to think of this platform as one way that we can help to encourage young, Black males, Black females to study STEM, right? Particularly physics we're talking about now, but what else can actually be done to generate that interest and to combat these negative ideas early on, such that we have a lot of people applying for physics in the first place, and then we can, of course, maintain them in the programs from there on forward. What do you think?
Right. Yeah. So I want to comment on something specifically. I don't think that interest needs to be generated. I think the interest is there. I just think that a lot of experiences that young Black kids deal with suggest to them that despite that they have these interests in STEM, despite that fact, it turns out that that's not actually for them, right? That's the thing that we sort of really need to attack. How you do that is complicated. I mean, there are so many ways that young Black kids are discouraged from pursuing STEM fields. And a lot of it does have to do with this silly notion that we are somehow less capable of thinking about these sorts of problems in the world. And I think a lot of that is going to require replacing who it is in these jobs that are shepherding Black students, that have control over their education. Like how could it be possible for a Black child that's interested in STEM to succeed if their teacher doesn't believe that they're going to succeed? If their teacher isn't going to help them pursue their interests, help them investigate this thing, or imagine what happens if you express interest as a high school junior or something. You're Black and your counselor, isn't telling you about how, like, oh, this place is great for science and they have X, Y, and Z major. You would love this. But because they have these preconceived notions of what it is you can do, they don't help you in the way that they might be helping other people. So there's a lot about how, like, Black kids coming up through this educational system, in some cases, they are in these environments where people don't even necessarily believe in them or think highly of what they can accomplish. So I think that, changing that aspect of the educational system is important. Definitely doing this sort of outreach thing is important. I think outreach is incredibly important. Having these kids see that Black scientists exist. I like to make this point that I'm not a unicorn. Yes, I work hard. Yes, I'm talented at physics, but many Black people work hard. Many Black people are talented at physics and other science and really at everything. Right. And so I think that if young kids saw this more, that would probably really encourage them. Right. We get blasted by the media, a certain picture of what it means to be Black, but we are not a monolith. Black people do many things. We exist in many avenues. And so I think exposing young Black kids to more of what it is to be Black is important, because part of being Black is to be a scientist. Absolutely. Science is a Black thing. It always has been.
Right. Yeah. So we need more fresh professors. That's basically
that's right.
What you're getting at. Yeah, absolutely. No, that's cool. And so, but in terms of potential solutions, at least, I'm sure that your existence and how forward facing you are in terms of speaking so openly about your experience in STEM and talking about all the cool science that you do should certainly be encouraging to younger students who may be now potentially interested in studying physics.
Right. Yeah, I certainly hope so. That's definitely a large part of the point. So
yeah. And so very quickly on the final note on this, I don't want to take too much of your time, but I want to ask, so we mentioned that there's a lot of conversation happening right now around these issues on campus. I know that BGIS, the Black Graduate Engineering and Science students, have sent out a menu of accommodations. I know that I chatted today with BGSA, the Black Graduate Student Association, about things that they're doing as well and conversations that they're having with administration. I'm curious if you think that there's any real change that we'll actually get out of all these conversations that are being had, or if you think that this is going to go back to being swept under the table when something else interesting happens that distracts us from all the things that have been happening in Black America over the last several centuries.
Yeah, I think that things are going to change. And I think that a part of why they're going to change is because we are not going to let people forget.
Absolutely.
We're not going to let people not think about these things. I'm certainly not going to let that happen. There's something that feels special about this time. Right? I do think that there are a lot of well-meaning but hollow actions happening where people, maybe put up some Black Lives Matter statement, and that's the extent of their action. I mean, I know several examples of people putting up a Black Lives Matter statement on their social media and then 10 minutes later doing something incredibly anti-Black. Incredibly. Right? So there will be those. But there are also a lot of people that are a lot of non-Black people putting in a lot of work trying to unlearn racist behavior, try to unlearn anti-Black behavior. Right. And yeah, I think the combination of people putting in what feels like more effort than usual and people being constantly reminded, like, hey, this isn't just going to go away. This isn't a fad. This is my life. This is our lives.
Absolutely.
Yeah, I think it's going to change. And hopefully I'm become part of the professoriate and I can give some very strong pushes to help it change.
Absolutely. Yeah. And hopefully I'll be right there behind you. So
great. Oh yeah, I think you will.
Great. And so Charles, man, thank you so much for coming out and chatting with us today. This has been very enriching. Please do continue to do all of the great work that you've been doing, both on the physics side and on the social side, by writing important articles like the one that you wrote for Physics Today.
Thank you. I appreciate it. Very happy to be here. This is incredible. Thank you.
Yeah, of course. Good. Thank you. All right, guys. So listen, if you enjoyed our conversation, which I'm hoping you did, I mean, Dr. Charles, he dropped some gems on us today. Definitely make sure that you drop a like to thank him. And if you have any questions for me, for Dr. Charles, definitely just feel free to drop them in the comments below. Share this with a friend, the usual. All right. So thanks again. We'll see you in the next one.